Hello and welcome back to my channel. Today in this video we are going to discuss the solution of Cambridge A-Level Mathematics, Pure Mathematics 3 from Feb-March 2025, and it is 970932. So let's start with the question number 1. So the question is, solve the equation ln 1 minus e to the power 2x negative 2x plus 3 equals 0 and give your answer, final answer correct to 4 decimal places. So we know that if we need to convert from the log form to exponent form, we need something like ln a equals b, and then you can write a equals e to the power b. So first of all we'll write in that form, which means ln of 1 minus e to the power negative 2x equals negative 3. Means from here we can write 1 minus e to the power negative 2x equals e to the power negative 3, and we need to find the x. So I'll transfer this term to this side, or and e to the power negative 3 here. So I'll get 1 minus e to the power negative 3 equals e to the power negative 2x, or I can rewrite this thing as 1 over, because we have the negative exponent, if I send it in the denominator it will become positive exponent, and now I can take the cross multiplication. So this become e to the power 2x equals 1 over 1 minus e to the power negative 3. So I transfer everything to the denominator here, and this denominator came here, so it become this. Now if I use the from exponent form to log, we'll get 2x equals ln of 1 over 1 minus e to the power negative 3. So from here we can see that x is half ln 1 over 1 minus e to the power negative 3. There is no need to simplify and write this e to the power negative 3 as 1 over e to the power 3, because we are going to write the whole thing, this whole thing in the calculator display in the calculator, so that we can get the direct answer. So I will get this from the calculator, and it is 0.02553 and so on. So till 4 decimal places we can see this 1 2 3 4, and the next number is less than 5, so we'll write x as, so the value is 0.0255. so that's the answer. I hope it is clear. Let's discuss the second question. Here's the second question. The equation of a curve is xy squared plus ln x plus 2y equals 1. So the equation of the curve is given in the implicit form. Find the gradient of the curve at point where x equals 0. So if we need to find the gradient of the curve, we need to differentiate it, and since the equation of curve is given in the implicit form, so we'll use the differentiation of implicit function, and we know we are going to find the gradient at where x is 0, so we also need y, because y is also involved in this. So I'll plug the x value as 0 in this original equation of the curve to get the y. So we'll get 0 times y squared plus ln x, means which is 0 plus 2y equals 1. This got vanished and we are left with ln 2y equals 1. So from here we get 2y equals e to the power 1. Again the simple rule, if ln a equals b, then a is e to the power b. So I got 2y equals e to the power 1, or basically just e. So now I'll differentiate this. So or you can say, like, if we can mention the points explicitly where x is 0, so it is 0 comma half e. So now we'll differentiate this, differentiating both the side. See, this one is going to be the product rule, so x times first function as such, differentiation of the second function, that is y square, derivative is 2y into dy over dx, plus second function as such, and the derivative of x is just 1, so I'll leave just as y squared, plus ln derivative of ln fx is 1 over fx into f dash x, so this is going to be 1 over x plus 2y into derivative of this, which is 1 plus 2 dy over dx, and derivative of a constant is 0, so this is equals to 0. Now we need to find the gradient of the curve. Either we can just get this dy over dx explicitly, or we can also say that the gradient of the curve at where x is 0 is given by is denoted by m, and we replace this x value and y value as this directly in this equation. So I'll rewrite this in the explicit form. So I'll collect dy over dx from here. I get x into 2y from this, and I can factor out this dy over dx, which is going to be plus 2 over x plus 2y, and then this is into dy over dx. From here we got y squared. From here I got 1 over x plus 2y equals 0. So we can directly write dy over dx from here, which is going to be dy over dx equals this whole thing to the left and right hand side, which makes it negative, and then y squared plus 1 over x plus 2y over x into 2y. The reason behind writing 2y together, because we know that 2y is just e, so plus 2 over x plus 2y. Now we'll just plug the x value. So the gradient at 0 comma half e is denoted by dy over dx. This equals to negative of y squared, means the square of this, 1 over 4 e squared, plus 1 over 0 plus 2e, 2y is just e, over x means 0, so 0 times e plus 2 over 0 plus e. So if we simplify this, we get it as 1/4 of e to the power 2 plus 1 over e divided by 2 over e. Now we know that we have 4 and e here, and denominator is also e, so we can take the same denominator. We can make the same denominator and cancel out e. So we can rewrite this thing as, the numerator of this is 1 over 4e, and I'm taking the LCM of this two, which can be written as just like a 1 over 4e. So it is 4e, and this term, first one would be e cubed and second term would be 4, divided by 2 over e. So now these two e's got cancelled out, and we are left with negative 1 over 8 times e cubed plus 4. This 4 will come in the denominator, so it become 1 over 8. So that's the gradient. We can also write the numerical equivalent, but it's not mentioned, so we can leave it here as well. I hope it is clear. Let's discuss the next question. And here is the question number 3. The shaded region on the Argand diagram shows points representing complex number z defined by two inequalities. The shaded region is bounded by a circle and a line parallel to the real axis. So the boundaries of the regions are included in the shaded region. So there are few informations given, and we need to find the two inequalities in terms of z that define the shaded region. So we can see that we have a circle and a complex number which has only the fixed imaginary point, imaginary value or imaginary part. So if we take the circle in the in the complex number, to define a circle we need the radius and the center. So here we can see the center is given as negative 2 comma 1, and the radius is, if we measure this radius is 3 here. So the definition of a circle in the complex number is z minus z1, modulus of z minus z1 equals to r, where z1 denotes the center of the circle and r denotes the radius of the circle. We need to check the we are not only talking about the circle, the boundary, we are also considering the region. So if in order to define this region, we need to first of all talk about the whole disk, like the complete filled circle, and the imaginary part of the complex number which is below it. If we take the intersection of these two, then only we'll get this region. So first inequalities would be, in this case we are going to take the less than or equals to 3. So here in this case z1 is -2 plus iota. So the inequality, first inequality become modulus of z minus -2 plus iota, which is center, is less than or equals to radius, which is 3. Or we can simplify this and write modulus z minus negative, or so it becomes plus 2 minus iota less than or equals to 3. That's the first part, first inequality. We need two inequalities. So another inequality, as we have seen, the imaginary part should be less than this, so that it includes this region in the intersection. So the second one would be imaginary part of z should be less than or equals to -1. We can see it is at negative iota, so it is going to be less than or equals to -1. So these are the two inequalities which define this region, shaded region. I hope it is clear. Let's discuss the B part of it. And here is the B part. Find the greatest value of modulus of z from the point in this region. So we need to find the greatest value of modulus z, and we know the modulus z basically means the distance from the origin. That's why modulus z can also be written as z minus 0. So this is the distance from origin. So we can see basically they are talking about this point, because this is the point which is in this region. This is going to be the at the farthest. So here we know the imaginary value, which is, if I take z as 1, so this value is going to be -1, and all we need to find is the corresponding x value. So let us take z equals to x plus iota y, and we have y as -1. This is confirmed because this is the point we are finding the distance. So technically we are finding this distance. This is the modulus z. So from the previous part we can see that we have the equation of circle. The equation of circle was modulus z minus 2. So this coordinate was -2 comma 1. So the equation of circle, if you see, it is going to be minus plus minus 2 iota, modulus z plus 2 iota. This was supposed to be 3 for this situation because this point is lying on the circle. So if we plug this value here, we will get it as x plus iota y. So we can write minus iota plus 2 minus iota equals 3. So if we simplify, we get it as x plus 2 as the real part minus 2 iota equals to 3. So the modulus of this is going to be square root of this square, which is x plus 2 whole squared, plus the square of the imaginary part, which is going to be 4. This is 3. Or if we take the square of both the side, if we square both the side, we are left with x plus 2 whole squared plus 4 equals 9, or x plus 2 whole squared equals to 9 minus 4, which is 5. So from here we got x plus 2 as plus minus root 5, and we know this point is it's in the third quadrant, so any which way this value of x has to be negative. So we will take this thing as x equals -2 minus root 5. Will not take positive because this point is in the third quadrant. So that's the x value. Now we got y as well as x from here, so we can calculate the the modulus of z, which is modulus of -2 minus root 5 squared plus y squared, that is 1. Hence we simplify this, that is going to be 4 plus 2 root 5, sorry, not 2 root 5, it is going to be 2 times root 5, that is 4 root 5 plus square of root 5, that is 5 plus 1, and hence this become root of 10 plus 4 root 5, and that's the answer for the modulus of z. I hope it is clear. Let's discuss the next part. And here is question number 4. By first expressing the equation tan x minus 60 degree equals to cot x as a quadratic equation in tan x, solve the equation for x between 0 and 180 inclusively. So here we can see that we are going to simplify using the tan a minus b from here, and we already know that tan a minus b is tan a minus tan b over 1 plus tan a into tan b, and in this case the b is 60 degrees, so tan b, which is tan 60 degree, is root 3. I wrote it explicitly so that I can directly use, and hence we got this thing as tan x minus tan 60, which is root 3 over 1 plus tan x into tan x into tan 60 means root 3 times tan x. It's better to write root 3 towards the left side of tan x. This equals to 2 cot x, so I can write it as 2 over cot x. Oh, sorry, 2 over tan x, because cot is reciprocal of tan, so 2 over tan x. And now I'll do the cross multiplication, so we get it as tan x times tan x minus root 3 equals 2 times 1 plus root 3 tan x, and hence this can be written as tan square x minus root 3 tan x, and this is going to be 2 plus 2 root 3 tan x, so I'll send this to the left hand side. It becomes minus 2 root 3 tan x minus 2 equals 0, and here we got this thing as a quadratic in tan x, so tan square x minus 3 root 3 tan x minus 2 equals 0. And since it is quadratic in tan x, and then I'll need to find the tan x to get the x value, so I will use the quadratic formula. So from here we got tan x equals to minus b, means 3 root 3 plus minus square root of b squared, means square of 3 root 3, that become 9 into 3 27, minus 4 ac, so it become positive 8 over 2, means this is 3 root 3 plus minus root 35 over 2. Now we will calculate this value. We'll get the two values, one with positive sign, another with negative sign. We'll get the two values from the calculator. So with positive sign we get it as 5.5561 and so on, and with if we take the negative sign here, we will get it as negative 0.35996 and so on. So from here we got tan x as both positive and negative, and we know that we need to find the x value within 0 and 180 degrees. So from here the first one is going to be, if we take x equals to tan inverse of the first value, which is 5.5561 and so on, and this value is going to be 79.797 and so on, which is still 3 significant figure is 79.8 degree. And if we take the negative sign here, we will get it as x equals to tan inverse of negative 0.35996 and so on, which value is negative 19.797 and so on. And we know that if we want to find the next value from here, we have to do the 180 plus, which is going to exceed the limit, because we had to find x between 0 and 180 degree. So we will take this as a final value from here, and from here we can get the next value by taking 180 plus, because that's a periodic property of tan, plus the angle which we got. So from here we got it as 160.202 and so on. So we will take the final value as x equals to 160.2 degree. So these are the two solutions for this equation. So that's it for this video. I hope it was of some help. Let's meet in the next video. Till then, thank you so much.